Okay, so this is the continuation of the last two videos. If you are new to videos, then let me tell you, we are doing the questions based on the concepts which we have learned so far in the previous videos. So as you can see, there are plenty of questions in this video. And we are going to cover more than 10 questions in this video. So this will be slightly lengthier than the previous videos, okay? So without any further ado, let's get started. So in question number 23, okay, so let me tell you, there is not 22 number because there is some mistake in numbering. Okay, so right after 21, there is 23. So please do not get confused. So in question number 23, we are given demand relation and supply relation, and we are asked to calculate the equilibrium price and quantity. So let's go to GeoGebra. So the demand relation is x equals to 100 minus 2y plus 0.1 times py is given 14 plus 1.5 times population is 181. Okay, and then supply is x equals to 2y. Let's see where is the intersection point. Let's find out this point. So as you can see, quantity is 186.45 and the price is 93.23. Okay, now in the next question we are asked to calculate the total economic surplus. So total economic surplus is simply this bigger triangle. Okay, so let's find out these 2 points. Now area of BCA is 17,381.8. So this is economic surplus. And in the next question, PY is still 14 and there is increment in the population to 199, and we are asked to calculate the equilibrium price and quantity. So I'm going to change the population here to 199. Okay, so as you can see, the equilibrium price and quantity has changed here. So quantity is 199.95 and price is 99.98. So this is your answer. Now in the next question, again we are asked to calculate the total economic surplus. So I have already calculated this. This is 19,990. In the next question, consider the welfare of the consumers who originally reside in the country. Before the increase in population, total consumer surplus is. Now we are asked to calculate the consumer surplus. So we need one more curve, y equals to y coordinate of A. Now we need to find out one more point. Okay, so the consumer surplus is simply the area of BDA. Okay, so the upper triangle. So area BDA. So this is 9,995, right? BDA. Okay, so this is the consumer surplus. All right. Did I do some mistake? I think I did a mistake. Okay, so this is before increase in population, right? So let me change here 181. Okay, so now you can see this is 8,690.9. so this is the consumer surplus. Okay, so this is the answer for question number 27, before the increase in population. Now you are asked after increase in population, what is the consumer surplus? So you need to draw one more curve in this case. So let me copy this whole demand relation, paste it here. I'm gonna change the population to 199, and also I need to change this equation to equation 2. So as you can see, due to the increase in population, the demand curve has shifted up. Okay, Now I need supply relation, x equals to 2y. Okay, now let's find out these intersections. Okay, now in order to find out the consumer surplus, I need one more horizontal line. So y equals to y coordinate of f. Now as you can see, the question has asked that consumers who originally reside in the country. Okay, so we need to find out the consumer surplus with respect to the original demand curve, but the starting point should be after the increase in population. Okay, so let me show you what I mean by this. So this is the new equilibrium, right? This f point is the new equilibrium due to the increase in population, but we need to find out the consumer surplus starting from this curve to the original demand curve. Okay, because this represents the population who originally reside in the country, right? Okay, so let's find out the area of this region. The region B, G, okay, and this point as well, B, G, and H. All right. So area is B, G, and H. So this is 7,477.93. All right. Now in the next question, okay, so we have done question number 28. And the next question, consumers who originally reside in the country as a group is willing to pay to lobby the government. Okay, so we need to find out the amount that they can offer to the government, to fight against. Okay, so the second answer is against the immigration policy. So now you can see, let me draw one more curve. Y equals to passing through the original, equilibrium, that is E. So initially the consumer surplus was starting from this equilibrium point, right? But after the increase in population, the equilibrium moved up. So we used GH curve. So in order to lobby the government, we need to calculate this area. Okay. So I need to find out this point. All right. So the area G, I, E, and H. So this is 1200, all right. So this is the answer to this question, and the second answer is against the immigration policy. Now let's move on to the next question. We are given P, Q, and price elasticity of supply, and the supply curve must have strictly positive y-intercept. Why? Because the price elasticity is greater than 1, which means the supply curve is elastic. Okay, so supply curve should have the positive y-intercept. All right, now let's move on to the next question. We are given the price elasticity of demand, price elasticity of supply, and supply curve decreases by 4%. This leads to increase in the equilibrium price and decrease in the equilibrium quantity. So in the previous video, I have mentioned one formula, if you remember. So the formula is percentage change in price due to the shift in supply. Okay, so let me write down the formula. Let me go to Notepad. So this is percentage change in price equals to minus percentage change in supply divided by the absolute elasticity of demand, because the demand elasticity of demand is negative, so we need to take the positive sign, and then the elasticity of supply. So there are two formulas in the previous video, so I'm using elasticity formula because in the question we are given values in elasticity. Okay, so now you can see the change in supply curve is negative 4%. So this becomes positive, negative, negative, positive, and elasticity of demand is given, elasticity of supply is also given. Please remember, you should take the positive value of elasticity of demand. All right, and then you find out the change in percentage change in price, and after that use the simple definition formula of elasticity, that is elasticity. Okay, elasticity of demand is equals to percentage change in quantity demanded divided by percentage, divided by percentage, okay, percentage change in price. All right, so you are given elasticity of demand. All right, so this is minus 0.3, and then okay, so from the upper equation, so this equation, you can find out the percentage change in price, and then there is only one quantity unknown, that is percentage change in quantity, so you can find out this as well. So this is how you can obtain answer for this question. Okay, so I'm not gonna solve it. I hope you can do it. Let's move on to the next question. All right, so you are given a demand relation, and at a point, okay, so this is the quantity, you are given the cross price elasticity, and you are asked to calculate the PV. So again, this is very simple. This is simply based on the formula. So the cross price elasticity, I hope you remember the formula. Let me write it down. So cross price elasticity at a point is simply PB. So the B is in the subscript. Okay, so then QA, let me put it in the bracket, times 1 over slope. All right, so what is the slope? Slope is 1 over minus 1.2. so this whole term becomes minus 1.2. okay, and then you are given the cross price elasticity and quantity. I hope you can calculate the PV. All right, let's move on to the next question. So you are given a table of values where there is price, quantity demanded, quantity supplied, and you are asked to calculate the new equilibrium price paid by consumers when there is a tax of $30. So let's go to GeoGebra. Let me clear the screen. Now let's plot a few points so that we can obtain the demand and supply curve. So let's plot the first point, 320, 40, and I'll choose one point that is equilibrium. Okay, so 170, 70. So let me see where are the points. Okay, so these 2 points form a demand curve. Now in order to draw the supply curve, you only need 1 point, because you already have this equilibrium, right, which is going to be intersection of these 2 curves. So let me take the first point, 20, 40. So when you join these 2 points, you'll obtain supply curve. Okay, now you need to impose a tax of $30. So let's say, suppose x equals to 150. Now you need to measure the length of this portion. This is a small portion. Okay, and you need to make sure that the length is $30. So first I need to find out the intersection point, and then I can measure the length. That is the distance of D. So you can see this is 8. Now I need to move this to the left. So let me change the setting first. This is fixed, right? So I'm gonna unfix this, and then move it. Okay, so as you can see, I can move this curve now. So this is increasing. Okay, so this is through 29. Okay, so this is almost 30, right? You can make it exact 30. Now, what is the equilibrium price paid by consumers? So when you right click on this point, so this is the demand curve, right? So when you right click on this point, you will see the price is 85.01. Okay, now if the tax is exactly $30, then you will see the answer is 85. Okay, so it depends upon you. Otherwise this is correct. Now, what is the tax revenue? In the next question, we are asked to calculate the tax revenue. So tax revenue is simply when you, okay, so let me draw two more curves, y equals to y coordinate of D and y equals to y coordinate of E. Need to find out these 2 points. Okay, so the reason the area FGED gives tax revenue, right? So area F, G, E, and D. So this is 2850.35. Okay, so this is the tax revenue. Now, in the next question, you are asked to impose a subsidy of $30. So again, this is quite opposite. You need to shift this curve to this side and make it, $30. So let me move this curve to this side and let's make it 30. Okay, so this is almost 30. All right. Now, okay, so what is the equilibrium quantity? So when you right click on this point, you can see that the equilibrium quantity is 245.02. If this is exactly 30, then you'll see the quantity is 245. Okay, so it doesn't matter. It is just a very minor difference. Okay, so let's move on to the next question. So in question number 36, you are given a demand relation and a marginal cost, and you are asked to calculate per unit tax at which government tax revenue is maximized. So let's clear the screen first. Demand relation is x equals to 113.4.2 y, and marginal cost is y equals to $9. Now please note, this is not the supply curve, this is marginal cost. So let's find out these 2 points. And you know that the tax revenue is maximum at the midpoint of the demand curve. So initially this whole curve is the original demand curve, but now since you are given the marginal cost, you need to imagine that AB is the demand curve and then find out the midpoint of AB. That will give you the per unit tax. So midpoint of AB. Now we need to draw a vertical line passing through C to find out another intersection, and then distance CD, distance C comma D. So this is 8.95. All right, so this is the answer of this question. Let's move on to the next question. Now in this question, you are given a slope of demand curve and slope of supply curve. Okay, and you are also given the price, equilibrium price, and price elasticity of demand. Then you are asked to calculate the equilibrium quantity. So this is very easy. You need to use the formula of point elasticity. Let me write it for you in the notepad. Okay, let me do it in the GeoGebra, because we need to do the other questions, the follow-up questions, so it's easier to visualize in the GeoGebra. Okay, let me clear the screen. So let me write the formula first, because you using the formula you can obtain the equilibrium quantity. Okay, so after once equilibrium quantity is known, then you can calculate the subsequent questions. Okay, so price elasticity at a point is simply P divided by Q times 1 over slope. This is times 1 over slope. All right, now your given price, okay, equilibrium price, and then price elasticity of demand minus 0.6. okay, and then you can find out the quantity, and the slope is also given. So when you put all these values, you will get quantity equals to 83.33. okay, so this is the first answer. Now using this quantity, we can draw demand and supply curve. So quantity is 83.33 and price is, in the question, $50. Okay, so let's see where is the point on the graph. All right, now I'm drawing a arbitrary supply curve, passing through this point, but I need to make sure that the slope of the supply curve is 1. okay, so I need to adjust that curve. I need to shift that curve a little bit so that the slope becomes 1. So first let me draw the random. Let's say this is the supply curve. Now I need to move this curve. Okay, so first let's see what is the slope of this line. So you can see the slope is 0.47, so I need to increase the slope. So let me shift this down. You can see the slope is increasing. I'm gonna stop when it reaches to exactly 1. Okay, so this is exactly 1 now. Now the demand curve will also pass through this point, right? Because this is the equilibrium point. So this is the intersection. So the demand curve will also pass through this point. Now using this point and slope, you are given the slope -1. So you have a formula that, okay, let me write down the formula as well. So 1y minus y1 equals to slope times x minus x1. So x1 and y1 are the given point and slope is the given slope in the question. So when you put the values, you'll get the equation of the demand, and then you can simply write the equation here. So I have already obtained the equation, so let me write it. So this is x plus y equals to 133.33. so this is your demand curve, and in order to confirm this, you can measure the slope. So as you can see, the slope is -1. All right, now suppose the government now provides a 4.8 per unit subsidy. What is the price paid by the buyers? So let's say x equals to $100. Now the length of this portion should be 4.8, right? This portion. So let's find out the intersection first and the distance, and we need to adjust in such a way that the length becomes 4.8. okay, so I need to change the setting. Let's unfix this. Now I can move this curve. Let's make it 4.8. Okay, so this is not exactly 4.8. Let me make it exactly 4.8. It can take some time because there is a very minor difference. All right, so you try shifting the curves. Okay, so this is exactly $4.8. All right, now you are asked to calculate the price paid by the buyers as well as the price received by the sellers. So since this is the supply curve, you can right click at this point and you can see price is 52.39. all right, so this is the price received by the sellers. Now what is the price paid by the buyers? So similarly on the demand curve, you can right click on this point and this is 47.6. so this is the price paid by the buyers. Now in the next question, okay, so the quantity in question number 39, what is the quantity traded? So what is the increment in the quantity traded? So you need to find out the length of this portion. Okay, so let me draw a straight line. Y equals to passing through A, and let's find out the intersection of this point, this line and this line. Okay, let's measure the distance. So up to this point, right? So this is 2.4. okay, so the quantity traded increases by 2.4 units. All right, now let's move on to the next question. In question number 40, you are asked to calculate the consumer surplus and producer surplus combined with this subsidy. Okay, so I need to draw one more curve passing through this point. So with this point, this is D. So y equals to y coordinate of D. Now you can see that, you know, the area G, F and D, you know, this whole big rectangle gives you the consumer surplus after the subsidy, right? Similarly, this area, you know, this whole area up to the point, up to this point and this point C, this whole entire area gives you the producer surplus. So when you compare, you know, the consumer and producer surplus with the original equilibrium, so this is the original equilibrium, right? And you know, this whole area is the original consumer surplus and this is the original producer surplus. So you can see that the only increment in the consumer and producer surplus is this area, right, up to this point and C and D. So this is the area, you know, this area has increased after subsidy. So we only need to find out this area. So let me find out one more point. So this is the point and area H, F, okay, D, and what is this point? I think this is A. So A and C. Okay, so this is 405.58. all right, so this is the answer to this question. So the consumer and the producer surplus will increase by 405 point something unit. Okay, now if per unit subsidy reduces to 2.4, what is the deadweight loss change? So now let's change the subsidy to 2.4. so let's move this curve Okay, let me move this 2.4, right? I need to increase. Okay. So let's make it 2.4. Okay, so this is not exactly 2.4. Oh, I need to look at this point, this distance. All right, I was looking at the wrong distance, so sorry for this. 2.4, right? 2.4. Okay, it's kind of hard to make it exact. Okay, so this is almost 2.4. All right, so now to find out the deadweight loss, you simply need to calculate the area CAD. So area CA and D. So this is 1.43. All right. So the deadweight loss is 1.43, but you are asked to calculate the changes in deadweight loss. So initially, okay, so now you remember this point 1.43. Now let me press Ctrl G. Okay, so you can see the uh, the length of CD has reversed to 2.42. Okay, so let me press Ctrl G again and again. So before this the subsidy was, okay, so before it was 4.8, right? So let me see. Okay, so this is 4.7. Let me make it 4.8. Okay, so this is almost 4.8. Now you can see the area of CAD. Okay, so let me calculate again. Area of CAD, this is 5.6, right? Before it was 1.43 and now it is 5.76. So there is the change, change of 4.33 unit, right? So the answer is 4.33. Okay, so you need to also put the negative sign because the change is negative. So the answer is minus 4.32. All right. And the last question, suppose the supply and demand curve of a product are both linear. After a $3 per unit tax is imposed on the product, $60 deadweight loss is observed. Based on this information, we can conclude the tax reduces the quantity traded by. Now, we need to make the tax to $3. Okay, so let's see. Let's move this line to this side and let's increase this until we reaches $3, right? Okay, so $3. Okay, so this is almost $3. And what is the deadweight loss? So CAD is the deadweight loss, right? So you can see, okay, so the question says $60 deadweight loss is observed. Okay, so in this question, you don't need to draw the graph. You simply, you can calculate this using the formula. Okay, you can see that, this is the deadweight loss, right? CAD is the deadweight loss. Now, in order to calculate the area of this triangle, you have the formula 1/2 times this length, right? Okay, this length A to up to this point. Okay, this point is not visible clearly. So from A to this point times CD, the length of CD. Okay, that's the area of deadweight loss. So now using this formula, we can find out the changes in quantity, because when you look at this, the changes in quantity is simply this length A to D, because this is our tax, right? And this is the quantity at this point, and this is the equilibrium. So the change should be this length. Now let me write the formula. So the deadweight loss, that is $60, should be equal to 1/2 times tax, because this is the length CD is tax, right? And in the question it is given $3, so this is 3 times, and change in quantity. Okay, so you can solve this and you can find out the change in quantity. All right, so this will be 40 units. You can find out the answer. This will come out to be 40 units. Okay, now let's move to the second last question. You are given the demand and supply relation, and then you are asked to increase the employment by 96. So you're basically asked to increase the quantity by 96, and then what should be the subsidy and deadweight loss. So let's do this quickly. So the demand relation is 20,000 minus 25y, and then x equals to 75y minus 20,000. Okay, so let's see where is this curves. Now let me change the aspect ratio so that the curve looks nicer. Okay, you can see it looks nicer now. This is the intersection point, equilibrium. As you can see in the question, equilibrium point is given, and you can match this with this answer. This is 400 and this is 10,000. Okay, now we need to increase the quantity to 96, okay, by 96. So let's say, suppose x equals to this is, yeah, we can increase, basically we can increase this equilibrium quantity by 96. So we simply can write 10,096. Okay, so when you zoom it, you can see this has increased by 96, as you can see. Okay, so this is 96. Now you can find out the length of this portion. This is subsidy. Let's find out this quickly. So the distance B comma C, this is 5.12. all right, so this is the answer to the first question. And deadweight loss is simply the area BAC. This is 245.76. now in the next question, suppose the financial secretary would like to use subsidy to increase the employment, but he does not want the deadweight loss to exceed 700. So we need to limit the deadweight loss to 700. So let me change the setting so that we can shift the curve to the right. So you can see I can move this curve now, and you can notice here the area is also changing. The area BAC is changing, and we have to make this to how much? 700. Okay, so it should not exceed 700. So the maximum you can make it to 700. Okay, so let's make it to 700. Okay, so this is almost 700. all right, so the maximum subsidy, you can see the length of BC here, this is 8.64. all right, so this is your answer. Now let's move on to the last question. Darren bought a ticket to a football game, $201, and a ticket to concert, $381. Okay, so this is bought by Joy. Both events will be held at the same time, and tickets are non-refundable. So please note, tickets are non-refundable. Joy finds the football game to be interesting and offers to directly swap tickets with Darren. Suppose that Darren values the game at $269 and concert at $400. What is the opportunity cost of rejecting Joy offer? Okay, and going to the football game. So you can see that the tickets are non-refundable. Okay, so the Darren's opportunity cost is simply the you know the value that he has for concert, that is $400. Okay, because you know the ticket to concert bought by Joy is simply non-refundable. Okay, so whatever is the value by Darren for the concert is the opportunity cost. So this is $400. All right, so we have finished all remaining questions in this video. Okay, so, I think the video is already too long, so let's stop this here. Thank you so much for watching this video.